This is an introduction to section 16.5. In this section, we're starting off with our position equation here, which is actually the same equation that we had back in chapter 12. That was equation 1233. So in this equation, we say, if we have a fixed reference system using coordinates x and y, we use that to measure the position of point B and the position of point A. Those two vectors are related by our equation here. If you take the position of A and you add to that the position of B measured with respect to A, then you get the position of B. And we have a new coordinate system here, which is the x prime, y prime coordinate system. This coordinate system can translate, but it does not rotate, and the origin of this coordinate system is point A. So if you're standing at point A, this is what you would measure for the position of B. This is the position of B as measured by A. Now, if you take the time derivative of this equation, you get equation 1234. That is given to you in section 16.5 as equation 1615, but on the next page, we're going to combine this equation with equation 1610, where we have the velocity as the angular velocity crossed with the position vector, to get a new equation. This is equation 1616. So angular velocity crossed with the position of B with respect to A is the velocity of B with respect to A, which is what we had in equation 1615. And they tell you on page 347, if you're standing at point A, the bar appears to move as if it were rotating with an angular velocity about the z prime axis, which is passing through point A. Now, this velocity of B with respect to A, we can write like this, the angular velocity crossed with the position vector here. And if your 2 points, B and A, are points on the rod, if this rod is rotating and you're standing at point A, you're going to see or observe point B to be rotating, but it will only have angular velocity as it rotates around you. And if these are 2 points on the rod, B is not going to get closer to A or farther away from point A, so the distance between those points isn't changing. So you would just have rotational motion if you're an observer at point A looking at point B. So that's how we get equation 1616. And that's pretty much the only equation we're going to need for most of the problems in this section. You can read through the rest of this section on your own, and then we'll take a look at some example problems.